Hello, and welcome to Flash Forward. I'm Rose, and I'm your host. Flash Forward is a podcast about the future. Every week we explore a specific possible or not so possible future scenario. Everything from space pirates to antibiotic resistance. Every episode starts with a little field trip to the future before we zip back to today to talk to experts about how that future might really go down. Got it? Great. Let's start this episode in the year 2032.
Are you tired of trying every weight loss trick in the book? Sick of dieting and seeing no results? Fed up with endless trips to the gym and no change in the scale? There has got to be a better way. Well, now there is. Introducing Biome, the very first personalized weight loss solution that really works. Biome's patented personal microbiome technology will get you the results you deserve without having to give up your favorite foods or spend hours in the gym. Simply send us a few easy samples of your microbial world and we'll formulate a treatment just for you. And now, if you call in the next 20 minutes, you can get 2 months of Biome for the price of 1. Call now. Deals like this don't last.
Hi, welcome to Doderline. Can I get you some water? We have sparkling or ultra-filtered? No? Okay, let's go on a tour. I'm so glad you came by to see the school. It's so important to really understand what we do here so you can make the best choice for your little genius. The kids here get the very best educational experience. We combine an inquiry-based learning program with a wholly custom microbiome to activate every student's inner good genius. We believe that under the right conditions, every child can thrive wholly through inquiry, a healthy environment, and intellectual courage. Our application process is really simple. Once little Burton is born, we just need the doctor to swab him for the microbiome sample and then just send it to us. They know how to do it. You just say that you're applying to Doderline. They're familiar. We get so many applications, so that can be really hard to pick between the little geniuses that come through. But we really emphasize a holistic education, and we try to make sure that every student's inner ecosystem can fit and flourish here in ours. Okay, I'm blabbering. Take this pamphlet, and it explains everything, and if you have any questions, just call me. Anytime, just call.
Hello, today on The Maud Show, we're catching cheetahs. This woman says her man wasn't loyal, but he says she's being too suspicious. We turn to the test. Do their biomes match? Got science on our side here. Are his bugs gonna give him away or not? Stay tuned. Stay tuned for that and more. Okay, so in this future, we use our personal microbiome for everything from medicine to school to courts. But let's back up a little bit, because first we need to talk about what a microbiome actually is.
Okay, so every person contains tens of trillions of bacteria and other microbes in their gut, on their skin, in and around their bodies.
That's Ed Yong. He's a science writer for The Atlantic and the author of an upcoming book about microbes called I Contain Multitudes. It's hard to say exactly how many microbes make up the human microbiome, but researchers suggest that somewhere between 500 and 1,000 different species of bacteria live in the human gut. And that's just the gut. There are microbial communities in our mouths, on our skin, in our armpits, in the vagina, on the penis, all over the place. To put it in a different perspective, the average human body is made up of 30 trillion cells. And on top of those 30 trillion cells, the average human also carries around in and on it 40 trillion microbes. 40 trillion! And those 40 trillion microbes do all sorts of really important things for us.
We know that they help to sculpt our organs and tune our immune system and digest our food. They probably help to shape our behavior and to protect us from disease. So they're really important.
Because people's health seems to be at least correlated to so many different species of microbes, a lot of researchers are interested in kind of hacking that and saying, what are the microbes that, live in the gut that support, not being obese? And what are the ones that make you less likely to develop diabetes or, help protect you against the kind of bacterial infections that, cause really bad gastrointestinal illness.
That's Rachel Feltman. She's a science blogger for The Washington Post, and she actually suggested this episode. She's been tracking the future of the microbiome. So the premise here is this. There are these microbes living in and on you. Some of those microbes impact your health. And if we can control those microbes, we can make you healthier. People have talked about using microbiome-based medicine to treat everything from
having a pill you could take that kept you, or at least made it really unlikely for you to become overweight.
And on the flip side, malnutrition, diabetes and other metabolic disorders. They're looking at disorders of inflammation.
Creating kids who don't have allergies.
Allergies, asthma, type 1 diabetes, multiple sclerosis.
Could we hack the armpit microbiome to, keep people from having BO?
They are looking at cancer because there seem to be links between the microbiome and colon cancer. They're looking at heart disease.
Could we make yeast infections less common? That would be great.
Pick a condition. There's chances are there's some groups somewhere studying links between that and the microbiome. A lot of this excitement is justified. There is a lot of promise here. All the future that I talked about is potentially real. There's theoretically you could make that happen. You could get to a point where you're actually prescribing personalized cocktails of microbes to people in ways that significantly improve their health. I think that is entirely feasible.
But before we go too far into the future, let's talk about what we can do right now with the microbiome.
There are currently no drugs that are approved drugs in the market for doctors to prescribe that are microbiome based.
That's Jessica Richmond. She's the co-founder and CEO of a company called uBiome. Now, uBiome started as a crowdfunding campaign back in 2013.
Which is kind of a crazy way to start a biotech company, but we started with a crowdfunding campaign on Indiegogo. We had no idea whether or not it was going to work or anyone pay any attention at all. And we just, it just exploded fantastically. Within 10 weeks, we had over 2,500 people involved. It was $350,000, which at the time was just an unimaginable amount of money. It kept us going for the whole first year.
Now they're a fully fledged company that will sequence your microbiome for you.
You can order up to 5 sites. So there's nose, mouth, skin, gut, and genitals. So both male and female. So there's a vaginal kit and there's a penile kit. And what we do is we send you a box. It has a swab and some tubes in it, and you swab the affected areas. So for the gut microbiome, you swab the toilet paper. You use toilet paper, and for the vaginal microbiome, there's this protocol for swabbing the vaginal opening. For the mouth, you swab inside the mouth, and then you stick the swab in the tube, you shake it up, and you send it back to us. So it's a pretty easy process. It takes a minute to swab and then a minute to shake it up. You just put it in the mail and you send it to us.
When you get your results back, the uBiome team tries to tell you how your microbiome compares to everybody else's that they've sequenced, what species you have that are more abundant or less, and what you might want to know about those species. And they're hoping to add some clinical information to that soon. They haven't announced what tests they're doing yet, but it could be things like what your microbes might say about the drugs you should or shouldn't take, or how they might relate to that weird stomach issue you've been having.
Our mission is to take this data, get as much useful data as possible and turn that into insights that can be used to take this new emerging field of the microbiome and turn it into something really valuable that people can use.
But when it comes to using microbiome-related information for treatments and medicine, right now there's really only one application that reliably works. And that's for patients with an infection called Clostridium difficile, or C. diff.
This bacterium that causes really nasty diarrheal infections. The reason fecal transplant works so well for this particular condition is that people with C. diff, their guts are like a wasteland. They've been taking loads and loads of antibiotics that have kind of nuked the ecosystems in their digestive tract. And that's been replaced by this one incredibly weedy species, C. diff. Now, when you shove a load of other microbes, like a more thriving, diverse community from a donor stool into that system, it's much easier for them to then take over.
So in patients who are suffering from this infection, whose guts have been totally decimated, an input of healthy fecal matter can be life-saving.
It's miraculous. It works better than antibiotics. It works for people who have not been successful with antibiotics. And it seems like it might be, a pretty permanent change.
But most people aren't living with totally decimated guts. Most people have a group of bacteria living inside of them, which can sometimes go a little wonky. In those cases, fecal transplants don't work nearly as well because it's much harder for the new bacteria to overpower the existing ones.
So you need to plan this really carefully, using algorithms that can work out how those microbes will compete, nourish each other, have synergistic effects, maybe cancel each other out. You'd also want to think about, what are those microbes going to eat? So they're living things. A lot of probiotics don't establish in the gut. Why is that? Maybe you need to feed them with the right food. So maybe you want to put the patient on a specific diet that's going to nourish whatever microbes you've just given them in that pill.
There are a few other uses for microbiome treatments that are starting to gain traction. While most of the research is happening on gut microbes, the vagina is also full of microbes that impact not just the person with the vagina, but also any babies that might come out of that vagina.
We know that babies are kind of dosed with microbes during birth. And actually, a lot of people have done research on whether C-sections, prevent you from getting that, first wave of microbes that you're supposed to get from your mother's vaginal canal. So there was a study where researchers had basically swabbed babies born by cesarean with these wet wipes covered in their mom's microbes, and to see whether it gave them the same boost as babies who were born vaginally. So I think one of the first things that's going to happen is that doctors are going to be inoculating babies with whatever we've decided the optimal microbiome for a newborn baby is, the second they're born.
Now, this might all seem pretty simple. Make sure you've got the good bacteria in you and not the bad ones. But in reality, it's extremely complicated. First, there's no one optimum microbiome. So it's not like you can just say, here are all the good microbes you might need, or these other microbes are bad, let's get rid of them. Two different people can have two totally different microbiomes and both be completely healthy. Take the vagina, for example.
So the vagina is actually a really interesting case, a case study for the contextual nature of the microbiome, because for ages people thought that the healthy vaginal microbiome was dominated by lactobacillus, which acidifies the vagina and therefore makes it harder for more dangerous species to grow. But turns out that isn't quite true if you look at women who aren't white. So if you look like African American or Hispanic women, they have a lot of them have different communities, many of which aren't dominated by lactobacillus and yet are completely healthy. And then if you look at everyone, you see that actually those communities change a lot. They flip in and out of lots of different states in ways that seem to have nothing to do with the women's health outcomes.
So it's different for each person, and it changes too. Even just changing what you eat can totally change your microbiome.
We had an employee who did a butter, she went on to sort of a ketogenic diet that was mostly fat, just as a test to see how they would change her gut microbiome. And you can see really dramatically by day 2 of that diet, and day 3 even more so, you can kind of see that her microbiome really changed to sort of fat digesting bacteria versus, carbohydrate digesting bacteria.
Plus, it's not just that we all have different microbes in us and that also they are changing all the time. It's also that these microbes are living in this complicated system that is completely interconnected. It's a biome. It's an ecosystem. And anybody who's ever tried to manage an ecosystem can tell you that it's really hard.
A lot of people are looking at it from the point of view of a clinician. With the very straightforward and raw maths of clinical medicine. You want to add stuff that's good, take away stuff that's bad. And, it's much more like caring for a national park or tending to a garden. You want to make the right species grow, you want to get rid of weeds, you want to make sure that everything's watered correctly. These are acts of ecosystem engineering. They're acts of world building.
You might be familiar with some of the classic tales of ecosystem mismanagement, like when the cane toad was introduced all over the place, from Australia to Hawaii to the Philippines, to help fight pests that were eating the sugar cane there. Well, they did eat the pests eating the sugar cane, but they also ate everything else. And on top of that, they actually secrete toxins that kill pretty much any animal that touches them. In 2005, the Queensland government spent $1 million trying to get rid of the cane toad. We don't really want something like that happening in our stomach or our vagina. Ugh. And preventing that kind of thing means really shifting the way that doctors think about medicine. So microbiome-based medicine is at a weird place right now. There's a ton of potential. There are all kinds of things that it could be used for, but we're also not there yet. And that's often a place where weird things start to happen. People start to overpromise or try things at home that maybe they shouldn't, like DIY fecal transplants.
Every scientist I've spoken to who works on fecal transplants has heard from patients who tried it themselves for all sorts of different things.
Doing this kind of thing alone without a doctor at home is really dangerous, especially if you have a really bad infection that's left you particularly vulnerable.
Even if you think your family member is super healthy, it's possible they have something in their gut that is going to make you even sicker. So it's actually harder to get accepted as a poop donor than it is to get into Harvard.
It's also not clear what might happen to these people in the future.
Really, no one has done long-term studies about this stuff. So fecal transplants have had a resurgence in popularity in the last sort of 5 or 6 years, but there are still no really good long-term studies. And for something like that, you want to look at what people are going to be like 10 years down the line, and we just don't have that data.
Today, there are people trying to use fecal transplants and microbiomes for everything from autism to body odor to cosmetics, and each of those things might turn out to be legitimate, but we don't know nearly enough yet to know which ones are and which ones are not.
And that's something we want to be really careful about, because there's a lot of hype. Whenever there's a new breakthrough in science, there are people who kind of overshoot the mark a little bit and say, the microbiome, the microbiome changes with your mood, or the microbiome is affected by your thoughts. And that's probably true to some degree, right? Like your stress response can affect, the environment of your gut microbiota, which then affects, specific organisms. But to sort of paint it as your mood changes and then your microbiome changes is way oversimplifying something really complex.
And I think in some ways, the microbiome kind of lends itself to this pseudoscience, because there's something very holistic about it. It's like, you have these living things in you and around you, and you need to foster the right ones. I don't know. There is something kind of zen about it.
There's currently a lot of money going into microbiome research, and there will certainly be better treatments and clearer uses coming soon. But my favorite part of imagining futures is imagining how they might also go wrong. Could microbes be used on a Maury-style show to determine cheating, like we heard at the top? If your microbes match his, did you have a fling? Apparently, maybe?
Oh, that's absolutely true. In fact, researchers are already working on using the microbiome for forensic medicine or forensic science. I think there are actually several researchers who are working with police. I know of at least one to study the microbiome of bodies in murder cases, and how useful that can be. It can definitely be useful in determining time and place of death, and it could also be useful in, it's possible they could look for microbial fingerprints someday. Researchers have done work on whether microbial signatures could be as useful in sexual assault cases as DNA evidence.
Now, a huge piece of this puzzle is about data. Who gets your microbiome data? How is it secured? What are people allowed to do with it? Those are important questions, and we're actually going to talk about them next week in a similar but different episode. So stay tuned for that. It's going to be interesting. But in theory, there aren't that many nefarious things that someone could do if they got a hold of your microbiome data. it's not that useful, and it's not stable, like we mentioned. It might be different now than it was when you got it tested.
One negative effect of genetic information that microbiome information doesn't have presently is that, if you know that your parents have certain traits or other family members have certain traits, that may lead you to inevitable conclusions about yourself that you may or may not want to know.
But that probably won't stop people from trying to use the microbiome to tell us about the innate nature of certain people.
I don't want to underestimate the ways in which humans are capable of discriminating against other humans. I think people are entirely capable of surprising me.
You have, this obesity in your gut that's associated with alcoholism, because of the way it helps or hurts your, metabolism of ethanol. So, you should lose this child custody case because you're more prone to becoming an alcoholic. It's far-fetched, but, people do some really dumb things with personal data, so it's not out of the question.
I think one of our goals is to keep the world from being a dystopian microbiome-based novel. That's very important.
And if people start tying the microbiome to things like personality or maybe talent, who knows what might happen?
Maybe like to make it even crazier, you'll get people like deliberately trying to like get fecal transplants from celebrities. Everything has already been linked to the microbiome. Like, why not like personal success or, or like, I don't know, singing voice. Maybe someone's going to kidnap Beyonce and try and do a fecal transplant with her stools.
Oh my God.
If someone actually, I am not encouraging or condoning the kidnapping of Beyonce for a fecal transplant. That would be wrong, listeners.
For the record, no one affiliated with this podcast advocates kidnapping Beyonce or anyone else for any reason, especially not for their poop. Just so we're clear, please do not do that. What do you think? Would you have your microbiome sequenced? Do you think this data is useful? Is it overload? Is it both? Let's hear what some people thought about last week's episode, the one where we talked about killing all the mosquitoes in the world.
Hi, Rose. My name is Catherine. I just wanted to say that I think it would be worth it to get rid of all mosquitoes because even if it could possibly have ecological implications, I think the benefit to human health would be worth it.
I feel like one of the reasons this could work out is this isn't an irreversible thing if we do it right. If this does, as the example given in the podcast, affect the bat populations or some other unforeseen consequence, well, we could simply keep a controlled reservoir of the mosquitoes that were found to be pivotal and then just re-release them into the wild using the same method that we did to release the sterile males or the males with sterile offspring. So that's my opinion. Thanks for the podcast.
I had to call in because it's actually one of those questions that I ask my friends fairly often. It pretty commonly comes down to around a campfire on a summer night, everyone's going to sign on to getting rid of the mosquitoes regardless of the impacts. What I like to layer into that question is, if we knew one of the side effects was that we were to lose the dolphins as well, would we still eliminate mosquitoes? And I'll tell you, on a night in July around a campfire, a lot of people are willing to lose those dolphins and maybe give the porpoises a little more time in the limelight.
Hi, this is Nikki, Adam, and Austin in Hong Kong, and we would like to say that we think
you should kill them dead.
You should kill them dead.
You should kill them dead.
Yeah, we think this is no contest. Definitely make them go away, please.
Just kill them.
Just kill them. Thanks.
Also, I think that would be really cool if Google Maps joined forces with the genetically modified mosquitoes, and as they're traveling around making the maps, also spread the mosquitoes that would be particular to that area. Just a thought. Probably crazy. But anyway, thanks.
If you want to tell us what you think about each week's future, we'd love to hear from you. Call us and leave a voicemail at 347-927-1425. Or send a voice memo to info@flashforwardpod.com. For instructions on how to do that, you can go to our website. It will be on the homepage. And you don't just have to tell us what you think about this future. If you want to suggest a future or just tell us stuff you think is interesting, you can do that too. I love hearing your ideas, so keep sending them. Flash Forward is produced by me, Rose Eveleth, and is part of the Boing Boing podcast family. The intro music is by Asura, and the outro music is by Broke for Free. The episode art is by Matt Lubchansky. And if you think you've spotted one of the little references that I've hidden in this episode, email us at info@flashforwardpod.com. If you're right, I will send you something cool. Some of you might have heard us on Planet Money last week. If not, go check out that episode. It's really fun. It's about all the various promises and policies that the current presidential candidates are putting forward, and what would happen if they actually got their way. I'll put a link to that episode on the website in the show notes for this episode. And I did hide 2 references in that Planet Money episode, so if you can find them, let me know, and I will send you this little prize that I've made. If you like the show and you want to support us, there are a few ways you can do that too. We have a Patreon page where you can donate, which would be awesome. But if that's not in the cards for you, you can head to iTunes and leave us a nice review, or just tell your friends about us. Those things really do help. That's all for this future. Come back next week and we'll travel to a new one.